Alright, so we are going to solve systems of linear equation with 3 or more variables. So to do that, we're going to learn about matrices. So this is 10.3, section 10.3, matrices and systems of linear equations and operations with matrices in 10.4. So basically in 10.1 and 10.2 is just review from college algebra, solving systems of linear equations with 2 variables. So something like this, 2x minus y equals 5 or x plus 4y equals 7. So you learn in college algebra to solve this, you either do substitution or elimination, or graphically you graph the 2 lines and you see where they intersect, if they intersect. So in order to do 3 or more variables, we're going to look at matrices first. So let's review. So I'm going to use the substitution for the first system. So I'm going to substitute y from the first equation. So from the first equation, if I add y to both sides and subtract 5 from both sides, I'm going to get that 2x minus 5 equals y. And then I'm going to substitute, instead of y in the second equation, I'm going to put 2x minus 5. And then just work it out. I'm going to get x plus 8x minus 20 equals 7. Add the terms alike and then add 20 to both sides. I get 27. So I get that x equals 27 divided by 9, 3. Once I have x, I can go back to what y is. So y equals 2x minus 5. But I found that x is 3. So y is going to be 8 minus 5. 6 minus 5, just kidding, 1. So then the solution to this system is the pair xy, where x is 3 and y is 1. Okay, then another method that we learned in college algebra was elimination. So you look at your 2 equations and you decide on eliminating one variable. So I usually look at, can I do something to one equation? So can I multiply one equation by something such that when I add the 2 equations, one variable is multiplied? So I decide to eliminate y, and I need to multiply this by negative 4, because then I'll have negative 4y plus 4y, so the y's will cancel. You can also multiply this, if you choose to eliminate x, you can do this by 3 and this by negative 2. So let's see. I multiply an equation by negative 4, and it does not change the equation. I'm going to do it to both sides, so it's going to be negative 8x minus 4y equals negative 4. And then the second equation stays the same. And then I add the 2 equations, so it's going to be negative 5x, the y cancels, equals 10. So this will give me that x equals negative 2. And once I have an x, I can go into one of the equations. So for example, I'll go into the first one. So 2 times x plus y equals 1, but I found that x is negative 2. So then this will give me that y equals 1 plus 4, y equals 5. So then my solution is the x and y, which is negative 2 for x and 5 for y. So if you recall, a system that had a solution was called consistent system. And furthermore, it was called independent if there was exactly one solution. And graphically, this meant that when you graph the 2 lines, they intersect in one spot. And then we can also have the case dependent when it had infinitely many solutions. And that was when the 2 lines coincided. So you had one line and then you had the second line was exactly the first line. So there were infinitely many solutions. The 2 lines intersect in infinitely many places because they are the same. And finally, inconsistent system was there was no solution. And the graph was that the lines were parallel. So for no solution, when you solve the system, for example, if you solved it by elimination, you reached like a false statement. You reached like 0 equals 1 or something like that. So then you can say that there's no solution. And if you solved it and you got a true statement like 1 equals 1, then there were infinitely many solutions. So this is just review from college algebra. Okay, so to solve systems 3 by 3 and higher, we are going to use matrices. So we're going to look at matrices. So a matrix is simply a rectangular array of numbers. So example of a matrix, I can have 21, 23, 50, and then 7, 2, and 5. Okay, so this is an array of numbers, and if I put brackets like this is how we represent a matrix. And we usually give capital letters names for matrix, so I can say that A is the matrix that has how many rows? It has 2 rows, and how many columns? It has 3 columns. So we usually write that the matrix A is 2 by 3. So we put first the number of rows. We first put the number of rows and then the number of columns. Okay, so in general, M by M matrix is a rectangular array of numbers with M rows. So this is the number of rows and this is the number of columns. And you just write it like this. You just list the first row, the second row, and so on. So if this is a matrix A, this is how we would write it. And we say that the dimension of the matrix is M by N. So M by N, we read this M by N, where M is the number of rows and N is the number of columns. So if I look at a certain entry, for example, A32 right here, A32 is the entry that is in row 3 and column 2. Other examples of matrices. Let's call this matrix B, 0, 1, 1, 1. This is a 2 by 2 matrix. The matrix C, what if I have something like this? What is the dimension of this? Well, how many rows do I have? It's 1 by how many columns? 1, 2, 3. What about this matrix? 1, 0, 0, 0, 1, 0, 0, 0, 1. Well, I have 3 rows, so it's a 3 by 3 columns. This is called an identity matrix because if I multiply any matrix by this, we'll see later when we talk about multiplication, I get the same matrix. So this does not change. This is like multiplying by 1 the real numbers. All right, so what can we do with matrices? Well, we can add matrices, you can subtract, we can multiply, and we'll see in section 10.5 that we cannot divide matrices, but matrices have an inverse. Well, some matrices do. So let's see. If I have these matrices A, B, C, and D, let's practice. What is the dimension of A? Well, I have 3 rows and 2 columns. What about B? I have 3 rows, so it's 3 by 2. What about C? C is 2 rows by 3 columns. And then D is 2 rows by 3 columns as well. So we can do all of these operations, but we have to pay attention to the size of the matrix. I can only add and subtract matrices of same sizes. So let's see, what is A plus B? A plus B, they're both 3 by 2, so I can add them. So you can think of it like I can like combining terms alike. I can't combine a x plus a y, but I can combine an x plus a 2x, okay? So A plus B, the result is going to be a 3 by 2 matrix as well. So if I add a 3 by 2 with another 3 by 2, I get a 3 by 2 matrix. So I know I'm going to have 3 rows and 2 columns. And we simply just add the entries, the corresponding entries. So 2 plus 1 is going to be 3. Negative 3 plus 0 is going to be negative 3. And then 0 plus negative 3 is negative 3. 5 plus 1 is 6. 7 plus 2 is 9. And then negative 1/2 plus 2. What is that? That's negative. If I multiply by 2 over 2, I have 4 minus 1, 3/2. Okay, so a plus b is positive 3, negative 3, 9, negative 3, 6, and 3/2. What about c minus d? Well, c is a 2 by 3 and d is a 2 by 3. So the result is going to be a 2 by 3. So we can subtract them. So c minus d, I take the entry in c and subtract the entry in d. So 7 minus 6. 7 minus 6 is 1. Negative 3 minus 0 is negative 3. 0 minus negative 6 is positive 6. And then 0 minus 8 is minus 8. 1 minus 1 is 0. And then 5 minus 9 is negative 4. What about c plus a? C is 2 by 3 and a is 3 by 2. They are not the same size, so I cannot add c plus a. Cannot add c plus a because they are not the same size. Okay, we can also multiply a matrix by a constant or a scalar. We call this 5 a constant or a scalar. So basically, 5 times a, what's the matrix a? 2, negative 3, 0, 5, 7, negative 1/2. Each entry in the matrix is getting multiplied by 5. So I'm going to have 10, 5 times 2, 5 times negative 3 is negative 15, 5 times 0 is 0, 5 times 5 is 25, 5 times 7 is 35, and 5 times negative 1/2 is negative 5/2. So if I need to multiply by a scalar, each entry in the matrix is going to get multiplied by a scalar. Okay, then the last type of operation we can do with matrices, we have to multiply them. So multiplying them is a little more complicated, but not too much. So a times c, what is the size of a? A is 3 by 2, so a is 3 by 2, and then c is 2 by 3. Okay, so we can only multiply matrices if these two numbers agree. If these two numbers agree, so meaning the number of columns of the first matrix equals the number of rows of the second matrix. So if these two numbers agree, I can multiply them, and the result is going to be a 3 by 3. Okay, 3 by 3. It's like these two cancel, so you'll have 3 by 3. All right, so let's see what is a times c and how to multiply. So a times c, it helps if you write what a is: 2, negative 3, 0, 5, 7, negative 1/2. And then c is 7, negative 3, 0, 0, 1, and 5. And we know that the result is going to be a 3 by 3. So I'm going to have 3 rows and 3 columns. So what's going to go in the first entry? So basically what I'm going to do, I'm going to look at the first row and the first column, and I'm going to multiply and add the corresponding entries. So in the first row, I'm going to have 2 times 7 plus negative 3 times 0. I'm going to write everything. Okay, so the first row and times the first column is going to go as the first element. Then the second element in here is going to be the first row, because I'm still writing the first row in the result. It's going to be the first row, but I'm writing the second in the second column. So it's going to be the first row times the second column. So it's going to be 2 times negative 3 this times this plus negative 3 times 1. Okay? And then the third element, because remember this is going to be a 3 by 3, the third element, I'm still multiplying the first row of A with the third row of the C. So it's going to be 2 times 0 plus negative 3 times 5. And then that's it. So we are done with the first row. Now the second row times the first column, so it's going to be 0 times 7 plus 5 times 0. And then for the second element, I'm going to do 0 times negative 3 plus 5 times 1. And then for the third one, I'm going to do the second column, 0 times 0, which is 0, plus 5 times 5. So we're done with the second row. Now in the third row, I'm going to take the third row of A times the first column of C, so it's going to be 7 times 7 plus negative 1/2 times 0. And then in the second column, 7 times negative 3 plus 1 times negative 1/2. And then 7 times 0 plus 5 times negative 1/2. Okay, so my answer for A times C is going to be 2 times 7, 14 plus 0, so just 14, negative 6 minus 3, negative 9, 0, negative 3 times 5, negative 15, and then 0, and then 5, and then 25, and then 49, negative 21 minus 1/2. So negative 21 minus 1/2, I multiply by 2 over 2. So it's going to be negative 42 minus 1 over 2. So it's going to be negative 43 over 2. And then 7 times 0 is 0, and 5 times negative 1/2 is negative 5/2. So this is the A times C, and it's a 3 by 3 matrix. So to multiply two matrices, first you have to decide if you can, and then get the result by following this rule. You multiply the first row times each column, and that's going to be in the first row of the result matrix, and then the second row times each column is going to go here, and then the third row times each column is going to go there. What about, can I multiply A times B? So let's look at A. A is 3 by 2. Can I multiply 3 by 2 by B is 3 by 2? So do these two numbers agree? No, they don't. This has 2 rows and this has this has 2 columns and this has 3 rows. So cannot, they don't agree. Cannot multiply. So how are we going to use matrices to solve linear systems? Well, it is going to be straightforward. So let's see that if we have a linear system like this, so we're moving on to having 3 variables, x, y, and z, we're going to simplify this notation by writing what we call an augmented matrix. An augmented matrix is just the coefficient. So if you look at the first line, the coefficient of x is 3, so 3 goes there. The coefficient of y is negative 2, so negative 2 goes there. The coefficient of z is 1, so 1 goes there. And then the free term is 5. So this is how I can convert a linear system, the information given by the linear system. I'm going to write it in this, what we call an augmented matrix. This is a simplified form because I don't have x, y's, and z in here. So the trick is going to be, I'm going to do something to this matrix, and then in the end, I'm going to get the solution for the system. And you'll see how. We can even write this system in what we call in matrix form. So another notation, it could be that I'm going to put just the matrix of the coefficients times the matrix of your variables. So x, y, and z. X, y, and z are my variables. So I can arrange them in a matrix with 3 rows and 1 column. And then the free term, the constant term right here, 5, 0, 11, can also be organized in a matrix with 3 rows and 1 column. So then in here, it's just going to go the matrix of coefficients. So 3, -2, 1, and then 1, 3, and -1. And then -1 for x. Notice I don't have a y term in here, so I can think about it as 0 times y. So this is a 0 here. And then 4 for z. So this is the equation, the system in matrix form. So notice that previously, if I have a system and I interchange the first equation with the second equation, I'm not changing the system. I'm just writing it in a different way. So in a matrix, row operations that we are allowed to do without changing the matrices are swap two rows. Okay, so if I write 1, 3, -1 first and then this one second, this is the same as rewriting the system in a different order, which does not change the system. So swapping 2 rows in a matrix is not going to change the matrix. Also, recall that in the first page we multiplied everything by -4. So I don't change the system if I multiply both sides of one equation by -4 or a constant. So I can multiply a row by a constant, and that does not change the matrix, because multiplying 1 row in the system does not change the matrix. And then I can add or subtract 2 rows. I can add or subtract 2 rows, or one multiple of a row to another row. We'll talk about this on the next page. All right. So next we're going to look how to solve systems using matrices.